friends, welcome to lesson 2. In this chapter, we will unbox the wish tree kit and also learn about the schematics. By the end of this chapter, you will have a good understanding of how to read the circuit diagrams and create circuits out of them. Let's quickly unbox and see what's there inside this IoT Bees box. Let's open. Okay, so firstly there is a note explaining all the features of this kit and the whole series. So this one is the Wish Tree's first beginner kit, which is IoT Bees kit, which is for completely new learners. The goal is to understand the fundamentals of getting into IoT and suitable for kids also. They have also given a lot of links and way to reach out to them. This is our Arduino Uno, that is the development board, and we'll be talking about this in depth in our next lessons. Then we have the cable to connect this with our computer. This is the power box where you can have 4 1.5 AA batteries that will come up to 6 volts, and this connector goes into the Uno for powering it when we are not connecting or using it with computer and we want to leave it in our projects. So this is how you can power your Arduino Uno. Then we have jumper wires, male to female, female to female, and also a band for male to male. This is our solderless breadboard. This is a special, very important component in the kit because this will help you create circuits without getting into soldering or PCB design or of that sort. This is primarily used for creating the prototypes, and you can very easily get started without the knowledge of soldering and stuff like that. Then I see there is a LCD OLED display, a cute little display. So you can use this to show your messages or readings in the circuit itself. Next is our door sensor. This is the magnet, and here inside it has a read switch. It is basically a switch that gets switched on or off based on the fact that whether there is a magnetic field around it or not. We'll also learn about this one in detail in our projects. This is our SR04 ultrasonic distance measuring sensor. This is used to calculate the distance between the sensor and the object in front. It is very often used in robotic cars or projects of that sort. Here is our humidity and temperature sensor. So you can use it to create a weather station kind of a project. Then I see there is a packet with a lot of components. So here we have 4 types of resistances. One is 100 ohms, then 1 kilo ohms, 470 ohms, and 10 kilo ohm resistances. Next is our diode. Then we have got 2 buzzers. There are 2 potentiometers. These are variable resistances. So if you see, there is a nut, and when you rotate it, the resistance of this device would change. Basically a variable resistance. Then there are 3 sets of LEDs, green, red, and blue. Then there are 3 LDRs. They are light dependent resistances. Basically, whenever light falls on them, the resistance value between the legs changes. And at the end, there are 3 momentary switches, simple push to on switch.
While working with electronic projects, you would often hear this word, which is schematics. It is also known as circuit diagrams. Schematic is nothing else but a diagrammatic representation of the whole system. So instead of using a real image of a resistor or a capacitor, you would represent them in the form of symbols, which we'll talk about in a second. Circuit diagrams can be created using a lot of tools or even on a paper. But here I'll use this particular software which is available free of cost and see how a circuit diagram is created. Here on the left hand side, you see the common symbols that are available in this software. So like for example, resistance is represented by this hash line. Then we have, let's say, a battery. So if you remember your physics class, then these are the symbols that you would have probably studied in your class as well, right? So battery is represented by this symbol where it has long wire and a shorter one, and again a long and a shorter one. This means two cells. The long line is for positive end and the shorter one represents the negative end. Let's say we want to create a simple LED bulb connection. So what I'll do is I'll pull up an LED from the diagram, and here this is the symbol for LED because it is a diode. The full form of LED is light emitting diode. So we see there is a diode symbol and two lines coming out of it, which represents there is light coming out of it. So let's say we want to create a simple schematic for this one. I'll rotate it. Now, you can create wirings connections just by simply dragging the line here. I'll add a breakpoint to give it a fine look. Then I'll connect the resistance with LED. And the other end of LED to the battery. There you go. So this is one of the simple circuit diagram which can be created on a breadboard. So here if you see, then wires are the connections. This is symbol for resistance. This is an LED, a battery. So you can in fact go ahead and try this thing using any resistor value and see what is the difference when you change the resistance values. You have four kind of resistance, correct? Go ahead and try this exercise where notice the difference in brightness of LED with the different values of resistance. The commonly used symbols in electronics and the symbols of components in our wish tree kit are here on my screen. The first one is LED. Then we have resistor that we saw in previous image already. Then next is the diode. This is the symbol for diode. This R3 is the potentiometer, the blue potentiometer where the resistance can be changed by twisting the nut on that potentiometer actually. This one is for LDR, light dependent resistance. This is our momentary switch, simple switch, push to on. Here is our buzzer, the round black buzzer that we have in the kit. This symbol is for read switch. This is the switch inside the door sensor, the white door sensor that we have. Then next is our battery pack. Thereafter, this is the symbol used for Arduino Uno. It shows all the pin configurations. So if you are creating a symbol or a circuit where Uno is the primary component, that you can use this one. Thereafter, we have the symbol for humidity and temperature sensor, the blue component in the kit, and you have SR04, which is ultrasonic sensor, and last one is the symbol for OLED screen. It has 4 pins that are represented over here. So now we have come to the end of this lesson, and I hope you have good understanding of all the components in the kit and their symbols and how to use them in the project. This brings us to the end of current lesson. In the next lesson, we will understand the details of ICs, various modules, and different sensors in our kit. So, see you there.